Welcome back to Further Solutions Academy. Welcome back to Further Solutions Academy. On this video, I'll be walking you through binary operation. It's a very simple part of mathematics, binary operation. And by the end of this video, you will know what is called binary operation. It should be a series because it's a bit wide, because we are going to be talking about property of binary operation, which is associativity, closure, distributive, identity, and inverse. Now everything will be on this series, but I will just explain definition and bit of examples on binary before moving on to closure, which is the next video. Now, if you are talking about binary operation, don't forget to share this video. Please subscribe if you have not subscribed before. Now, binary operation. A binary operation is any rule of combination of any two elements of a given non-empty set. Now, you know what is called set of a number? It means it must not be empty. For a set not to be empty, it means there is something present there, And at this point, when we talk about combination, it means we are talking about what? Our normal operation in mathematics. You know what is called operation? We have operation plus, we have operation minus, we have operation multiplication, and operation division. There are many of them, but I'll be working on long at this point, at this junction. I won't go a bit. There are equal to, there are greater than, there are less than, there are, not equals to. There are many of them, but I will be on this part. Please, I don't let me go deep, I don't want to be very deep, because once I'm deep, I'm getting into real analysis. I don't want us to be in that realm. Now, I have this particular operation with me. Now, but in this part, we have what is called operation, and we have what is called definition of what? Operation. Now, most time we use what is called, now for all what you are seeing here, we use what is called asterisk. Some people use something like this, some people use something like this, and some people use, some people can use plus on circle. Depends. That is what I'm talking about. Now, all these things can be represented by what? By this. Now, it means it must be an operation, and there must be a definition of what? Operation. Now, look at this operation. If I have a asterisk b equals to what? A squared plus b squared minus b. Look at this. This is operation, and this is definition of what? Operation. Now, this is what? Let me write it down. Operation. And here is what? Definition. Now, that is what we are talking about here. Now, if there is an operation, star, asterisk, whatever it is, there must be an definition of it. If not, there is a problem. Now, permit me to write one or two questions and see how it is. Don't forget operation, definition of what? Operation. At this point, I'm using operation star, operation asterisk. I can use this operation. They are the same thing. I can decide to write operate with this, which is equals to what? A squared plus b squared minus ab. Now, there is something about it. They are the same thing. I'm just like, what is there is I'm just playing around with what? The operation. Now, permit me to write one or two questions so that I will be able to see how this behave. It's a very simple part. You see that we are just relating around. Now, look at this question. Okay, look at this question. It's a very simple one. And let's see how we relate with operation. A binary operation star, which is asterisk, is defined by what? This is the operation. This is the definition of the operation. For instance, I can write this as this. This is a symbol that represents this. Sorry, permit me to write it down. For all, this is for all, because if I'm in the realm, I may be seeing something like this. For all can be represented by that. Now, such that there exists all those things I don't know to, let me not disturb you. Now, solution to this problem. Okay, when you talk about real numbers are commonly used number. They are number, when your graph, let me quickly explain graph to you. This is called real, and this is called imaginary. Now, all numbers you can find here, they are called real numbers. And all the numbers that numbers there are many. We have integer, we have rational, irrational, we have rational and irrational number, we have a decimal number, we have a whole number, we have a natural number. They are all in real number. It means the real number is the bigger set that contains all what I just mentioned now. Now you can see what I mean there. I think very soon there is a video I made earlier before now. You can check it on numbers. Sorry. Oh, sorry. Now on numbers. And this marker. Okay. Now I just want to work on this thing. Look at this. A operate with B will be equals to A squared plus B squared minus B. Now, at this junction, what is very important is I'm using this number now. Now, look at this. 3 operate with 2 will be equals to what? Now, it means indirectly A is 3, B is what? Please, positional matters here. Please don't mix it up. It's very important. I will be talking about 3 squared plus what? 2 squared minus 2. 9 and 4. That will be 9 plus 4 minus 2. You know, 9 plus, this is going to be 2 and 11. It means 3 operates with what? 2. On this definition, it will be equals to this. That is what you just need to learn there. Now, can somebody try to tell me this? You know, operate with 4. Okay. Now, we think it's a very simple one. I think if you can try it, it will be what? Minus 5, look at squared, plus 4 squared, and minus 4. Now, mind you, there's a problem that people normally understand and normally say mixed up. Now, if I have 2 squared, this is minus 4. But if I have minus 2 bracket of square, this is going to be what? 4. Now, this and this, they are not the same thing. You have to learn to make use of the bracket. I was talking to my set of students before now, you know, I was talking about them, how to use their operation. So that when they get to advance, they must to use bracket more instead of what? Multiplication. Because they serve the same thing. For instance, if I have 3, 2 multiplied by 4, this can be as well as written as what? 2 bracket of 4. They are the same thing. Now, but this one will give us clear picture of what you're about to find rather than this. Depends. Anyway, I mean, you know, that is what I want you to know there. This one will give us 25 plus 16 minus 4. Now, 16 take away there, it will be 12. Now, plus 12. Now, I think my 4 operate with this, it will be equals to, now this plus this, that will be 10, 25, 35, that will be 37. Now, that is your answer. You can see it's very simple. You can try this and you see that it's very, very, okay, try it, let me see. Okay, now, I want to do it by myself. Operate with 3. Now, it means my A, this is my A, and this is my B. Take note of that. And it means I'm saying that 7 squared plus what? 3 squared minus 3, which is 49 minus 9 plus 9 minus 3, which is going to be 9 drop down. Okay, plus 10. Okay, this that'll be 6. 6 plus 49, that'll be 55. Now, can you just say that this operates with this equals to that? Now, that is all about that. Now, I have another problem here, like 2 more questions. Permit me to write them down for better illustration. Binary operation. Okay, now, okay, let's walk along with these questions there, and let's see how it will go. The first one, the second one, and the third one, they are, you know, it can be a positive question, they can be a JRE question. I can remember this is from GRE Why this one is from POSITME, this one is from WAEC further mathematics. Now, I just want us to work on these particular problems. Let's see solution to this problem. Now, the first thing we need to understand here is that A operates with B, asterisk C operates with what? D, equals to A plus B, plus C all over AD. Now, note, this is operation, this is definition of the operation. Now, you can see the operation, the sign that I operating here, addition. Now, and you are asked to find this. It means 3 to divide 5 operates with what? 15 divide 6. Now, for your information, for you to know this very well, I think I will let you to know that at this point, my A will be equals to 3 whole number 1 all over 2, which is something as, which implies 7 all over 2. Mixed fraction, improper fraction. I think that is your A. A is equals to this. Now, your B equals to 5, your C equals to 15, and your D equals to what? 16. Now, for me to work on this particular point, it means I'm saying that what is my A? I can decide to turn it to this plus my C. My C is 15 divides B. B is 5 and multiply. This is multiply and 16. That is what we have to do there. That's what we have to do there. Now, at this junction, I can say that we have, permit me to, this is going to be 15, 30, 7 plus 30. I'll find the LCM. This is all over 1. And divided by 2. That is divided by, this one will be what? 16 times 2. That will be 1. 16 times 5 will be 160. We divided by 160. Now, this and this will be that will be 37 divided by 2 multiplied by 1 all over 160. Okay, is there anything that can divide these numbers that are here? Now, I think there's nothing I can use to divide it. Okay, there's nothing I can use to divide it. I think oh, don't mind me, sorry. 16 times, it should be 80. I'm so sorry. I was looking at it. This is going to be 80. I'm so sorry. Please, 80. Now, at this junction, it means I'm talking about 31 times 1 multiplied by 1. That would be 160. Sorry, my brain was, pouring what is already on it. Now, that is going to be the answer. It means that is the answer to the question. Now, look at this very good question. You are asked to solution to this problem. Now, look at this. It's very, very simple also. What is there is that this is the operation. This is the operation SY equals to, definition is this minus Y. For all XY belongs to what? R. Now, this is the operation. This is the definition. Now, what you just need to do now is that I will have what? 3 operate with M will be equals to what? 3 squared plus M squared minus M equals to what? 7, because it's been stated already. Now, at this junction, I'm saying that 9 plus M minus M equals to 7. I think I'll be having M squared, M, and that is going to be 9, and this will be 2. Will be what? Plus 2. Yes, plus 2 equals to what? 0. I've done the quadratic. I've done what I need to do there. Now, at this junction, I'm having something like this. I want to factorize. Now, what can I do? I will just do it this way by saying that what can I multiply to get 2 and add it to get 1 is 2 and 1. It means I'm saying that now factorize. Now, it means I'm saying that m squared plus 2m minus m minus 2. Okay. No. I think I'm sorry. 2 times 2. 2 times 1, 2. And for me to get minus 1, I think I'll have minus 2. This is going to be minus, sorry. And this is going to be plus. Now, at this junction, I'll be having m bracket of m minus 2. And this is going to be plus 1 bracket of m minus 2 equals to 0. This is going to be 0. Now, m equals to, okay, m plus 1 or m minus 2. Now, m equals to 1 minus 1 or m equals to 2. Now, m equals to minus 1 and 2. It means that is the answer. This is going to be answer. That is going to be answer. That is the answer. Now, I just need to move on to the next one. I have something like this, solution to this problem. This is very simple. Now, this is the operation K. We have m operate with m equals to m plus n squared. Now, that is the operation. Why I have k operate with 3 will be equals to what? Operate with 4. Now, at this junction, it means this is your m and this is your what? N. It means I will be saying that k plus 3 squared will be equals to 7 plus 4 squared. Now, k will be equals to 3 plus 4 squared minus 3 squared. Now, here will be 9 minus here will be 16, here will be 7. Now, for us to have something like this, this and this will be 7. 7 plus 7, that will be 14. Now, it means my k will be equals to 14. That is my value of k. Hope I'm not making a mistake. Now, that is the value of k. Now, can you see what is called definition and what is called operation? Operation and definition. On the next video, I'll be working on closure, which is close, when operation is closed, and so on and so forth. And I will show you some examples on tabular form of how to handle this type of problem using tabular form. Don't forget to share this video to your friend. Subscribe if you have not subscribed before. Once again, thanks for watching.